Here says the vector diagram below represents the horizontal component F of H and the vertical component F of V of a 24 Newton force acting at 35 degrees above the horizontal. Okay, so you have a vertical component force and you have a horizontal component force. Okay, of 24 Newtons. Okay, so that's the actual force itself. Okay, so if I was going to label this, I'd say F equals 24 Newtons. Okay, what else is important is that it's 35 degrees. That means that we have an angle. So again, how we represent angles, we use that simple theta, 35 degrees. My unknown. So they want to know the magnitudes of the components from that 24 Newton force. Okay, so what we're going to have to do, right, we don't know F of V, and we don't know F of H. Okay, you need to go to your reference table on page 6 under mechanics, and you will see only two formulas that have theta in it for angle, and those formulas look like the following. You're going to see AX equals A cosine theta, and then you'll find AY equals A sine theta. Okay, again, you can use them in that form, or you can use it as fx and fy. It really doesn't matter here. As you can tell, they did say the vertical force and the horizontal force. They're all the same thing. Fv and fy are the same. They respond to the vertical component of that 24 Newton force, and fh and fx also correspond to the horizontal component of that 24 Newton force. Okay, so let's start substituting. So I'm going to name mine FH to kind of stay consistent with the problem. Remember, that's the same thing as me saying F of X. So I have 24 Newtons times the cosine of 35 degrees. Okay, and likewise, I have FB equals FY, and again, that's 24 Newtons times the sine of 35 degrees. Okay, again, you want to make sure your calculator is in fact in degrees. 24 cosine of 35, I get that FH is equal to 19.7 Newtons, and I have 24 sine 35, and I got the following answer of 13.8 Newtons for FV. Okay, so let's go to my answer choices. F of H. All right, so I can tell the first one's no good, second one's no good, third one's no good. Fourth one seems like a real winner though, because this is close to 20 Newtons, and this one is close to 14 Newtons, okay? So that's all you have to do here. Okay, your rounding will definitely make sense. They're not going to choose crazy numbers for you to round with, so it should be straightforward. Okay. Number 9, a baseball bat exerts a force of magnitude F on a ball. If the mass of the bat is 3 times the mass of the ball, the magnitude of the force of the ball on the bat is. Okay, so let's kind of highlight some stuff here. So this baseball bat is exerting a force of magnitude F on the ball. Okay, so that's what this baseball bat is exerting on the ball. They're saying that the mass of the bat is 3 times the mass of the ball. So clearly, right, what would be the force of the ball on the bat? I know there's a lot of stuff going back and forth, so it's kind of like something that looks like this, like and a ball right here, right? This is your baseball. So they're saying that this baseball exerts a force F, and they want to know, well, what's the force that the ball exerts on the bat? So what ends up happening is this is Newton's third law. Okay, so you write Newton's third law. This is how you're going to justify it. If I push on the wall is going to push the same amount of force back onto me. It's just going to be in the opposite direction. So it's the same magnitude, same amount. It's just that the direction is different. And I kind of did that in class. Like I would constantly push against the wall, and then I would ask you, how much is the wall pushing back on me? And you'd always tell me it's the same because of Newton's third law. So remember, now I'm going to write it this way. Equal magnitude and opposite direction. Okay, so what does that mean for this question now? Well, you know that the baseball bat is exerting this force F on this ball. And according to Newton's third law, we know that that ball is exerting the same amount of force F back on that bat, regardless of all this. The bat is 3 times the mass of the ball. That's garbage. That's there to trick you, because what they want you to do is plug it into Newton's net force formula, and you'll get the wrong answer. Don't fall into their trap. They're there to provide fluff for you to get confused. You know better, okay? If you know Newton's law is solid, then you're going to have absolutely no problem, okay? Number 10. As a 5 times 10 to the 2 Newton basketball player jumps from the floor upwards to the basket, okay? So keep in mind, she's jumping up towards the basket. The magnitude of the force of her feet on the floor is 1 times 10 to the 3 newtons. As she jumps, the magnitude of the force of the floor on her feet is, well, again, they gave you some fluffy information here. This right here, if you recall, is known as a weight, okay? Anything that has the unit newtons, we know is a force, and weight is, in fact, a force, okay? That is the force of gravity on us. Weight and force of gravity are synonymous with one another, okay? But they're saying that this basketball player, she jumped up, right? And she had to exert some sort of force, which they said was 1.0 times 10 to the 3 newtons. Okay, so again, 1.0 times 10 to the 3. I just go 1, 2, 3. So that's really 1,000 newtons. Okay? They're saying that she exerted 1,000 newtons on the floor to push herself up. So they're saying, well, how much is the floor exerting back on her feet? Again, Newton's third law, okay? Equal and opposite. So same amount of force, just in the opposite direction. And look at my vectors that I drew on the diagram. Okay, so equal magnitude plus opposite direction. Okay, so what does that mean for the answer? 25 makes no sense. 100 makes no sense. 500 makes no sense. Only 1,000 makes sense because it's 1,000 newtons that she's exerting on the floor. The floor must be exerting 1,000 newtons back on her feet. That's why she does not fall through the ground. That's why we do not fall through the ground when we walk. That's why we do not fall through our seats when we sit down, right? Because the normal force that we are exerting on the ground, right? The floor is exerting the same amount back up at us, okay? So keep that in mind.